Imagine you could take a massive pile of text like a book, a set of news articles, a blog post, or even a Wikipedia page and instantly transform it into a visual map that shows how everything is connected. That would be pretty cool, right? That's also the main idea behind knowledge graphs. Presenting your data in a knowledge graph can help you uncover hidden connections between complex topics, track relationships between people, things, or even spot patterns in your own data. Building a knowledge graph from unstructured text used to require a lot of manual labor or complex machine learning models. But with the advance of AI and large language models nowadays, it's getting easier than ever before. So in today's video, I'm going to walk you through the concept of knowledge graphs, what they can be used for, and I also show you how to turn any text document into a knowledge graph in Python, using large language models such as OpenAI's GPT4o or even some open source large language models if you prefer. In the end, we'll develop a small web application that can generate smart and interactive knowledge graphs from any text. This can be a powerful tool that not only helps you make sense of complex information, but also reveals connections you might have missed. So what is a knowledge graph? In case you're not familiar with the concept, a knowledge graph is essentially a structured representation of entities and how they relate to each other. You can think of it as a massive mind map that gives you a bird's eye view of how people, places, or things and all the concepts are connected to each other by clearly defined relationships. Let me give you an example. I'll admit an embarrassing truth. I've never ever watched Game of Thrones. What a sad life, I know. So if you had to explain the series to me or anyone else who's been living under the rock, it's probably most effective to show me an overview of the key characters, their relationships, how they connected through friendships, alliances, rivalries, and battles, so that in a single glance, I'd be able to see who's connected to whom, who's plotting against whom, and how all the major storylines intersect. If it sounds interesting enough, I'd maybe consider watching it. Now, another thing you might be wondering, how does a knowledge graph differ from a traditional database or spreadsheet? In both cases, information is stored in tables with rows and columns, but this flat list of things quickly becomes impractical when dealing with complex relationships. A graph structure, on the other hand, organizes data in a network of nodes and edges where each node represents an entity like a person, a place, or a concept, and each edge represents a relationship, like this person works with or lives in, or this thing is a type of. So this is much more efficient and more visual. And yet the best part is that you can perform various mathematical operations across different parts of the graph too. Depending on the use cases, you might decide to calculate things like the shortest path between the nodes or identify the most influential nodes in the network through centrality measures, or you can also even detect clusters of related nodes using community detection algorithms. Knowledge graphs have already been using in many areas, from improving fraud detection to search engines and even drug discovery. Around 10 to 15 years ago, Google realized that knowledge graphs can help improve search results significantly compared to solely relying on matching keywords on user queries. Have you noticed that every time you go to Google search and search for a person or something, for example, Albert Einstein, you see an information panel on the right that shows the main information about him and all the related people who are his spouses, children, the place where he was born, and the organizations he worked for. These results come from a massive knowledge graph built by Google, which is a massive database of millions of facts about people, places, and things. This knowledge graph helps Google return accurate, factual, and highly relevant results for your queries. In another use case, knowledge graph has proved to boost the accuracy for retrieval augmented generation applications, or RAG. This is a common technique and application of generative AI for answering user queries on large datasets. So traditional RAG systems retrieve text passages similar to the user's query, which works well for straightforward questions. But when a query is complex, like connecting events across different multiple documents, the traditional RAG systems can struggle to provide accurate answers. That's where the graph RAG approach comes in. So how it works is that it constructs a knowledge graph from the source documents, identifying the key entities and their relationships. And this graph is then used to create a bottom-up clustering that organizes the data hierarchically into semantic clusters. So this clustering allows for a more holistic understanding of the dataset. So whenever someone asks about an entity, for example, Apple Inc., from all the different sources, it may identify that Apple Inc. is an entity in the knowledge graph from the source documents. Then it will retrieve all the different pieces of information related to Apple Inc. And so this approach allows the LLM to ground itself in the graph instead of only relying on keywords or semantic similarity, and therefore it can return the most relevant results related to this entity. Another example is given a user query that requires a higher understanding. For example, given the query, what are the top 5 themes in the data? The results using the graph RAG approach can retrieve the most detailed and relevant themes thanks to the semantic clustering that we just mentioned earlier. Another good use case for knowledge graph is fraud detection. Graphs can help detect transaction fraud rings and other sophisticated scams by looking at people, accounts, and transactions done between them. In drug research and discovery, knowledge graph is also helping with storing and analyzing complex relationships and interactions between drugs, diseases, symptoms, genes, proteins, and so on. And my favorite personal use case for knowledge graph is learning and study. Once I created a mind map for learning Python that includes all the concepts you need to know and how they're related. So many of you have found it super useful for your understanding. So this effectively turns a boring textbook into an interactive learning experience. Now you might wonder, if knowledge graphs are so awesome, why haven't we been using them all along? Well, before the rise of advanced language models, building a knowledge graph was quite a pain. It required a ton of human effort and domain expertise to extract entities and define their relationships accurately. People might also come up with some rules to do that, but as you can imagine, a rule-based method like that is highly inflexible and unscalable. Even when natural language processing techniques and machine learning models start appearing and improving, they can only do the work to some limited extent. These machine learning models most often only work well with English language because this is the language they are most trained for, and they also often struggled with nuances, context, and ambiguity in human language. But thanks to modern AI and large language models that can read and understand multiple languages, can process large volumes of text, and also to a great extent reason about it, they can help us extract entities and map the relationships in a much more automated way. To see how easy it is to create a knowledge graph, even if you don't know how to code or just want to play around and see how well it works, I ran a quick experiment using the LLM Knowledge Graph Builder from Neo4j. You may have heard of this company if you ever worked with graph database before. I used it to analyze a bunch of text I found on Wikipedia on Game of Thrones. So here is the website, lmgraphbuilder.neo4jlabs.com, and if you don't have a Neo4j instance yet, you can sign up for it, and then you get to download your Neo4j credentials. This is all for free, and now you can simply add your text file here. So I have this got.txt file where I have the text from the Wikipedia page, and then you can go ahead and preview graph. And here is the generated graph. It looks pretty cool, right? So I'm not interested in documents and chunks here, so let me uncheck this. And now we're left with all the entities that are mentioned in the Wikipedia page. All the information are extracted from the text file that we input into this graph. And here you can see that in the middle, we have Game of Thrones. We have the number of episodes is 73. It's named as one of the greatest television series of all time. So this is pretty cool. And we can see that from such a simple text, we can construct quite a good, overview of this series and all the stuff that are related to this series. And you can see that all the different colors here are all the different types of notes. So for example, we have here the book series. If we click on it, that is this book series, A Song of Ice and Fire. And we have the year here. The year are these two notes there, 2025 and 2022. Oh wow, 2025 we have a new series here, A Knight of the Seven Kingdoms. So looking forward to it. Okay, so that is a quick look of how a knowledge graph might look like on a small example. Now, for all the tech nerds out there, let me quickly show you how you can create such graph using Python, using a large language model of your choice, and generate such graph and create a Python application that also lets user input their own text and document and then generates and displays the graph nicely. So without further ado, let's get started. Alright, in this project walkthrough, we'll experiment with transforming raw text, for example, the opening paragraph of Albert Einstein's Wikipedia page, and turn this text into a knowledge graph of his main life details. So same information, but just represented differently with entities and relationships. Now, before diving into the code, let's talk a little bit about the technical implementation of this. Now, using LLMs, there are two possible ways we can consider to convert a raw text into a knowledge graph. The first way is to simply use a prompt-based approach. So we'll manually instruct an LLM to extract the entities and relationships from raw text with a prompt. Your prompt could look like this. You are a top-tier algorithm designed for extracting information in structured format to build a knowledge graph. Your task is to identify the entities and relations requested with the user prompt from a given text. You must generate the output in this and that format, and we can also add an example. So here's one example. You can extract a relationship in the following format. So here is the format with head and head type, relation, tail and tail type, and here is an example output for the LLM to follow. And then ideally, the LLM will return a response that aligns with what you specify here, and then after that, you can parse this output further to construct a knowledge graph. However, with this approach, there is no guarantee that the LLM's response will strictly follow this format that you provided. And also, you may get significantly different responses in different runs. So this is not ideal. Luckily, nowadays, many LLMs such as those from OpenAI and Google's Gemini support structured output. So what that means is that we can define the output format, for example here for the note and the relationship, and this will ensure that the entities and relationships are extracted in a structured predefined manner. This approach is also more preferable because it often results in a much more consistent and reliable outputs that you can use later on. So if you want to implement all this yourself, feel free to do that, but fortunately, there's a tool developed by LangChain called LLM Graph Transformer that can work with different LLMs and also automatically handles all these considerations and standardizations for you. For example, if we use an LLM that supports structured output, this LLM Graph Transformer tool will use the structured output approach. Otherwise, it will fall back to the prompt-based approach. And this tool also provides a lot of ready-to-use functionalities that makes your work a little bit easier. All right, so let's go to VS Code, and I have a knowledge graph project over here. Let me quickly create a virtual environment. I'm using Python 3.12 here. And let's now create a Jupyter notebook called knowledgegraph.ipynb, and this is for experimentation, and I want to show you how this actually all this works under the hood before we start creating the application in Streamlit. For this project, we will install a few different packages. So the first one is LangChain, also LangChain Experimental, LangChain OpenAI because we are using OpenAI's LLMs, so specifically GPT4o. And let's also install python.environment for importing the API key. And lastly, we also want to have PyVis, which is a network graph visualization package in Python, and we'll use it to visualize our knowledge graph later on. So let's go ahead and install these packages. Okay, so let's make sure that we have a .env file here that provides your OpenAI API key. You can create this API key in your OpenAI account and make sure that you have some credit there to be able to use the API. Now let's load this env file and get the API key from the environment variable. Next up, we'll import the LLM Graph Transformer tool from LangChain and together with the document module and the chat API module. Now let's define the LLM that we want to use for this project. In my case, I'm using GPT4o, so this is what I have in the model name. And next, we will also create a graph transformer object. So using the LLM graph transformer, we will also provide which LLM that we are using. That is the GPT4o model. And from then on, we can use this graph transformer object to convert documents into a graph object, and we'll see how it looks like in a bit. Now let's say we have some text over here. Let me just go to Wikipedia and copy this opening paragraph about Albert Einstein, and I'll paste it here as the text. So here's the text. Albert Einstein was a German-born theoretical physicist who was best known for the theory of relativity, etc. This text is quite simple, and now we can convert this text into a list of documents object like so. And then we can process the documents using the aConvert to graph documents function inside the graph transformer, and this will convert the documents into a list of graph documents. And note that this function is asynchronous, and so we are running it asynchronously because this allows us to process multiple documents in parallel. So this can reduce the wait time significantly, especially when you're dealing with multiple documents. And if we run this, we get back the graph document. So this is basically a list of the graph document object, and this is provided by LangChain. We can also print out the nodes and the relationships inside this object. So let's quickly print this out. So let's have a look. We can see that we have a list of nodes here. So the first node is Albert Einstein, which is of the type person. And we also have another node that is theory of relativity, that is a concept. And we also have quantum mechanics, which is also another concept, etc., etc. And similarly, we have relationships that have the source node. For example, here, the first one is Albert Einstein, and the target node is theory of relativity with the type of the relationship being the concept, etc. So as you can see, we already have quite a good output to be able to build a knowledge graph. And let's quickly visualize this output in a knowledge graph using PyVis. There are some nitty-gritty details of how PyVis work, and so I have already created a function here to convert this output into a network graph that PyVis can visualize. And I'll skip the nitty-gritty details. And if we run this function, we will get back a knowledge graph in an HTML file. And here is Albert Einstein's life in a nutshell. And with all the people he worked with all the theories that he developed, where he worked, and which awards that he received. I've also made the nodes have different colors which represent different types of nodes. So it can be a person, organization, or an award or a research field. Now this output is already great, and maybe it's already very usable for you, but what if we want to focus on a certain type of nodes? So for example, focus on only person or organization or location, and we don't care about other things. We can provide constraints and extra guidance for the LLM to do this. So this will help us focus on a specific type of entities or relationships that we deem relevant and that we really care about. To do this, we will provide a list of allowed nodes. So here I have a list of types of nodes that I find really interesting. So the person, organization, location, award, and research field. And after that, we can pass the list of allowed nodes here into the LLM graph transformer. And now this will extract only the types of nodes that we specified over here. And if we print out again the output nodes and relationships, we can see that we only have person, location, organization, award, and research field being included in this graph. So this is really cool. Similarly, we can also specify which relationships that we think are most relevant for our research. So now we also add the allowed relationships list as well. Basically, we will use a 3-element tuple format. For example, person, works at organization, and these basically represents the source node, the relationship type that is worked at, and the target node respectively. So this will guide the LLM to extract only the relationships that match these types of relationships that we defined. So if we try this out, we will get the output that includes only the relationships, the types of relationships that we specified earlier. This can potentially make the graph much more usable. And now again, let's visualize this knowledge graph where we have defined the types of nodes and relationships that we feel more relevant. And you can see that this network is much smaller and more simple than the other one, the original one that we created. Alright, so that was a little bit of a walkthrough of how we can implement this kind of workflow converting text into a knowledge graph using LangChain's graph transformer package. In the next step, we can take all the code that we have in the Jupyter notebook and put it in a Python file, and this includes all the needed packages and functions for our application. So to save time, I will speed up this part a little bit, and we also create another file which is app.py file for our Streamlit application. In the scope of this video, I won't go in depth into how to create a Streamlit application like this, but you have access to all the code that I show here for this application in the GitHub repository that I put in the video description. So feel free to check it out and use it however you like. To run this app, we'll also need to install Streamlit library as well. After that, we can run Streamlit run and the name of this file, which is app.py. And here is our application. This Streamlit app will allow users to choose whether to upload a TXT file or to copy the text directly into an input field. And once the user clicks on the Generate Knowledge Graph button, this whole application will start running, transforming the input text into a knowledge graph and showing it on the web app. This is an interactive graph where you can zoom in, zoom out, hover on the node, and filter the nodes and relationships. This is all created with the PyVis library. It's very simple, just with a few lines of code. So I hope this video sparks some new ideas for you for how to use LLM to convert text into knowledge graph and how you can use this knowledge graph for different purposes. Also, feel free to check out other project tutorials on my channel. And if you want to build a solid foundation in Python, machine learning and AI, and also building applications such as AI agents, please feel free to check out my Python for AI project course. In the past 10 months, I've put my heart and soul into building this comprehensive course for those of you who really want to level up your Python skill and also building the solid foundation in machine learning and AI. So if this is something for you, I hope to welcome you to this little community of more than 250 learners that have joined so far. Thank you for watching. Bye bye.